Okay, we're going to do series today, but before we do series, we probably should remember what a sequence is. Hang on. There we go.
What? Honestly, I'm going to pronounce everything my brother.
Okay, we're going to do part of it today and part of it tomorrow. I gave you both, right? Okay, Drew, hopefully you've done the problems. Okay, to do it, what's a sequence? No, it's a list of numbers in a definite order. No, we haven't gotten to series. We're going to do that. Now, spell it right. Definite order. Not right now. Okay, that's what a sequence is. Okay,
Is it in definite order?
in a definite order. Now, how do you find the limit of a sequence? Oh, well, that's what 8-1 was all about. You take the limit as n goes to infinity of a sub n. It could be 0, it could be some other random number, or it could be infinity. Yes. Yes. 0 is an important number, though, and we're going to see that today. One little theorem about that. Okay, so if I have the sequence 1, 1/2, 1/3, 1/4, 1/5, what is that sequence? A sub n is equal to 1 over n. And you remember the name of that? Harmonic. Very well known. Oh, we have 10 convergence tests, so we're going to get started on them today. We have 2 of them today. Okay. A series, if you add up the terms in the sequence, you get what they call a series. So I can add 1 plus 1/2 plus 1/3 plus 1/4, etc., plus 1 over n. And you may think that if I keep adding an infinite number of terms, that that will never converge. But some do. Some do. And actually, we'll do it geometrically, but not today. I just was thinking about this one geometrically. This is a harmonic series, and you will put it in your notes, and you will recognize it easily, and you will say, this diverges. Because what does it mean to converge? It means it would add up to a single number, and diverges means it's going to keep getting bigger and bigger and bigger. No, if you add that up, the sum is getting bigger and bigger and bigger. You're right, the terms in the sequence are getting smaller and smaller and smaller. What if the terms in the sequence didn't get to be smaller and smaller and smaller? What if you kept adding those up? It'd still be infinity. So one of the conditions to have a series converge, which I'll hit on again, is that the terms of these sequence in the sequence have to be going to 0. That's why the 0 is so important here. If you get a number, it's not going to work. I'll let you think about that. That one diverges. I will prove it to you, and I just thought of a geometric proof to do it. So it doesn't go to 0 fast enough. If I do this series, if I take this sequence 1 over n squared and add those up, that will converge. The question is, what does this exponent have to be so it will converge? Well, I don't know. I keep thinking if I keep adding something to something, it would always grow to be bigger and bigger and bigger. But it's not. We could do the Coke snowflake too. Okay. Now, when you add them up, this is an infinite number of terms here. Okay, guys? That's a series. You could have partial sums. So you could talk about the sum of the first one terms, which would be just A1. You could talk about the sum of the first two terms. Okay? This is going to be hard if you don't pay attention, which is equal to A1 plus A2. You could talk about the sum of the first three terms, which is A1 plus A2 plus A3. These are called partial sums. It's not the sum of the entire series. And then just to bother you more, you know what I could do with those partial sums? I could make it a new sequence. It's called the sequence of partial sums. Yes, this stuff is used in real life. If you are in biomedical engineering, they use this with the machines. They're called Taylor polynomials. They approximate complicated functions with simple polynomials, and we'll be doing that. Okay, you guys? Shh. Eric? You did linear approximations. We're going to go a little bit further than linear approximations. We're going to approximate with quadratics, quartics. Okay, so sequence is just a list of numbers in an order. A series is adding them up. But I could talk about these little partial sums, just adding up a finite number of the elements in my sequence. And then I could make another sequence out of that. I could keep going. And then I could add up those numbers and make another sequence yet. Yeah, it gets complicated. We're not going to do much with partial sums, just a little bit. And we're just going to talk about the first n terms. That's all we're going to do. But just to let you know that that's what you get. And I have this all printed up there so you can read through that. Okay. And I'm sorry the page number is wrong. Now, don't forget your little study packet. Remember the study packet for 8.1 through 8.4. If the limit of the sum of the first n terms as n goes to infinity is s, then it exists, then we have the sum of the infinite series. Oh, you're going to have more fun then later. You'll see. Nobody's ever done that, though. Okay, you're the first one who ever said that. Yeah. Oh, just wait. Okay. Now, you guys, this little sigma, that's a sigma, which means add them up. It's a counter. Now, where have you seen sigma? Have you seen it in statistics? Yeah, but that's a little sigma. Have you seen a capital sigma? It's the sum. It's a counter. Okay, you guys, we're probably never going to write it out as a limit, but that's what it is. When you ask for the summation, n equals 1, let's do a concrete example. Let's use a harmonic series. We're always looking for the limit of that, but we never really say, I want the limit of the series. But that's technically what you are doing. You are really going to be doing this. I'm going to add this up. N is equal to, or I have to use a different counter because I can't use n. I already used it. And this is just a counter. This little n here just counts. That's all it does. And so I would start with 1 and go to n, and then I'll take the limit and let n go to infinity. That's the formal way of writing it. But we're probably not going to write too much with the limits. We're just going to do the problems. But if you were in a real Calc 2 class at the University of Minnesota, yeah, they'd probably be particular about it. So how do I use this counter? First thing, n is going to start at 1. Okay? You missed 2 days. You need to really pay attention. So it's 1 over 1, and then you're going to put a plus sign. Then the counter is going to go up to 2. So then it's 1 over 2. Then the counter goes to 3. 1 over 3. And this is going to keep going. And my last one's not going to be 1 over n. This is the nth. This is plus. It's a sum. I'll get negatives if I put in an alternating sign. But right now, let's just deal with the pluses. And then this continues, doesn't it? It goes off to infinity. They're going to ask you for the nth term. It's n. It'll be in terms of n. Term. Can't write. Okay? Are we okay with what a series is? You're just going to add up a bunch of stuff. That's all. So if the limit is equal to s and it exists, then we just have the sum of the infinite series. And sometimes they exist, sometimes they don't. We are going to be doing some special cases, and we're going to be worried about whether or not these sums exist. Okay, next page. I'm already on the next page, actually. We're going to do geometric series. And notice it has 4 stars by it. You will see maybe 5 or 6 of these in the multiple choice. You're going to see a lot of these. You will see every multiple choice question I have on geometric series. You'll see every one. Huge emphasis. Well, these are kind of cool. Okay. Oh, I don't have that written on here? Oh, yeah, I do. This is a geometric series. Okay, you guys? You can talk about a geometric sequence. Matter of fact, if you want to go back, if you want to talk about an arithmetic sequence, just because I want some space here, let's add a page. Yes. Arithmetic. You have a common difference, but it's pronounced arithmetic. So 2, 4, 6, 8, 10. That's the arithmetic sequence, and these are doing what? Increasing by 2. In this situation, it's an adjective. Arithmetic is a noun. This is an adjective. I remember a little grammar. Okay, you have a geometric sequence. Now, these are sequences that would look like 2, 4, 8, 16, 32, 64. What are we doing here? We're not adding 2. We are multiplying by 2. This number you multiply, we're going to call R, which is a common ratio. When you see these and you get them, they're fun. But getting them is maybe not so easy. Okay, that's a geometric, and I should label this sequence. So there, and you should have seen both of these back in 8th grade or 7th grade. You've seen the penny problem, right? If you get 1 penny the first day, then you double it. You get 2 cents the second day. I'm not adding 2. We're going to double it, 4 cents. And then what? 8 cents. Okay. This is the sequence I have here. But then we can talk about the sum, and you can do a cumulative sum on your calculators. Actually, we'll do that. So we really want to add that up, and then that's your series. That's geometric, because I'm doing what? Multiplying by 2. Is that okay? Okay, Eric? So, when would you have $1 million? Not as long as you think. But don't forget you have to add them up. The series could be a number. This would, if you went forever, there's no limit to this. This would diverge. Series diverges. What is a series? Oh, can we find the nth term? I like that question. How can I write that? The next one's going to be what? Now, here's what I can do. This will help you. I think it'll help you. This is 2 to the 0. This is 2 to the first. This is 2 to the second. This is 2 to the third. What's the next one? 16, which is 2 to the fourth. So what would the nth term be? 2 to the n. And you're going to add them all up, starting with, but careful, what are we going to start with? I get a penny to begin with. N is not going to be 1. It's going to be what? 0. N equals 0, and we could go to infinity or whatever. Now, you guys, you have on your CAS calculators, those of you who have them, if you put a number in here, well, if you put a number in here and you have a new operating system, on the 84s, you can find the sum of that. You could also put it into lists. You could do a cumulative sum. If we had time, we would do all that. Maybe, no, I got to teach tomorrow. Okay. Because what's the first term? It's 1. It's not 2 to the first. Or could you write this starting at n equals 1, and then this would be 2 to the what? Not n minus 1. Okay, this is a geometric series. And you guess what they are? They're exponentials. Okay, Eric, these are exponential functions.
How much is this worth, Miss Goldman?
You can buy them for about 135.
Like the deal's fans.
And you get computer software with it. So it's a pretty good deal. Okay, be careful with the CAS calculators on the exam. Yes, you'll have them for the calculator part, but if you solve your problems using the CAS capability and you don't show the calculus, you will not get the points. You are only allowed the end derived, the FNINT, zeros and intersection, where you don't have to show work. Okay, now we can do these problems. Okay, that's a geometric series. Geometric. This is just like what I just did. My last case was r was equal to 2, wasn't it? Because we had 2 to the 0. Okay, that's what it looks like. Okay, r is going to be a constant. R is going to be equal to some number. And it's called the common ratio. And all you do is divide these. So to get from here to here, I multiply by r. To get to here, I multiply by r. Okay, so now I'm going to see if I can find a formula to see when and if these ever converge. What if r was equal to 1/2? So you want to do this. 1/2 to the n. Oops. 1/2 to the n, and n starting at, well, let's do n minus 1, n starting at 1. What's the first term of the sequence? Series. What's 1/2 to the 0? 1. Then it's plus 1/2 plus 1/4 plus 1/8 plus 1/16. It's going to 0 pretty fast. Do you think it converges to a value? Yes, it does. If you do it geometrically, I'll leave that open for you to do with a rectangle or a square. It's very cool. No, it's not 0. You started with 1. You added a half.
Oh, yeah. See, told you it's infinity, bro. That's what I thought the first time, too. The values approach 0.
Well, you have 1. And then you add half. Then you add what? A fourth.
Does it converge to 2?
And then you add an eighth. And then you add a 16th. Yeah, it converges to 2. Do you like that geometrically? It took a middle school teacher to teach me that one. Pardon? If I want to add this up. I have 1 whole pie here, or whatever. Then I have a half. So that's half my square. Then I have a fourth. And I have an eighth. You see, these are all getting smaller. If I divide the eighth in half, I get a 16th. If I keep going, I'm going to end up getting a whole square, right? Will it ever be more than a whole square? Then it converges to 2. But we'll have to find an algebraic way to do it. Okay, so here's what we're going to do. Can we get this to converge? You know what? We can actually find what S is. For all geometric series, if you have a finite number of terms, you can always find the sum of the first n terms. Always. So here's what I'm going to do. I'm going to write this down. S sub n equals a plus ar plus ar squared plus ar cubed and ar to the n. Sorry, it's a little bit bigger there. And then I'm going to multiply r times s. So I'm going to multiply r here. Now, you don't have to be able to do this, but it's kind of cool to see this. I'm going to multiply this side by r and this side by r. And I'm going to line it up, and I am going to subtract my new equation from my original equation. So on the left side, I'm going to subtract this. So it's minus r times s sub n. Okay, Eric? I'm going to line it up. So AR, I'm going to subtract, but I don't want it under the first term, do I? I want it under the second term, because what's going to happen when I do that? It's going to go to 0, isn't it? And then it's minus AR squared minus AR cubed, and it's going to be AR to the n. And then what's the last one? Minus AR to the n minus, no, wait, no, sorry, it's the one in between. A is a constant. Then I'm going to get AR to the n minus 1 minus AR to the n. Oh, and then what's the next one after that? Well, let's just subtract them. It's the one before this one. That's all. So if I multiply this by R, what's the last one I get? Multiply this by R, what do you get? What's the very last term? AR to the AR to the n plus 1. Okay, guys, I need you to just be quiet. You can play with your phones. Then we're not doing grades right now. Oh, it's a trick. Because now what's going to happen when I subtract these or add my negatives? Because I subtracted. It's this equation minus that equation. Well, what's going to happen? It's a trick. I've seen this before. You haven't. What do I get on the left side? S of n minus R S of n. Well, it doesn't all go to 0. Most of it does. This will go. This will go. This will go. The one right before this will go. This one is going to go. And what am I still left with, though? That thing, right? So that's going to be equal to, the A is still here. Well, wait, we got a lot more work to do with this. And then it's what? Minus AR to the n plus 1. Because it didn't go. What was the last term here? It was AR to the n. We did the sum of the first n terms. Remember back up here? We stopped right there. Then when I multiply by R, then this will be AR plus AR squared. And my last one is AR to the n plus 1.
Can we just left out the AR to the n minus 1?
Yes. But well, you'll see it again in the future. Okay, I want to solve for S of n. Yes, question? Well, we'll see. This is the sum of the first n terms. So if you wanted to add up the first 100 terms of the harmonics series, you could, and you're going to get a little formula. I don't want to add 1 plus a half plus a third plus a fourth. I don't want to do that 100 times. At least I don't want to do it. Or a million times, whatever. So let's factor out S of n. That's left with what? 1 minus R. Can I factor out an A here while I'm here? It's tempting, so why not? So it's A, and this is 1 minus R to the n plus 1. And we'll do that. Let's find the sum of the first 100 terms of the harmonic series. And divide by 1 minus R. Can you keep your feet so I don't trip? I already broke my arm once in my life. That's enough. 1 minus R, and then this is 1 minus R. So what's the sum of the first n terms? It's A over 1 minus R times this thing. Oh, I can't do the harmonic series because it's not geometric. But what about the 1/2 or 2? Should we do 2? What if we do 2, 4, 6, not 6, 8? What's the next one? Multiply by 2, 16, right? 32. What is this? This is 2 to the n, right? No, it's 2 to the n. So it's 2 cubed, 2 to the 4th, 2 to the 5th. Yeah, I'm right. 32. What's the next one? 64. So what if I want to add this up from 1? Do I just do 10? 100 is going to be big. 10 of 2 to the n. That's what this formula will do. Now, where am I starting? What's the A value for each one of these? Well, you're going to start right here. A is, remember on the series, so I have it up here still? Way up here, what's A? A is the very first term in your series. Then it's A times R. You could write this a couple different ways, by the way. There's more than one way to do this. So A is equal to 2. What's R equal to? 2, right?
But then 2 times 2.
It's okay. We're going to use a little formula here. And then what's n? N plus 1. because I got to put n plus 1 in here. I'm going to do the first 10, so what's n plus 1? 11. Now you can do this, or you want me to bring it up on the calculator, I can. I have the new version of it. So S of n is equal to 2 over 1 minus 2. Some of you are going to say, wait a minute, I'm not going to get a negative number. But it's 1 minus 2 to the 11th power. I'm just using this little formula right here to find the sum of the first 10 terms. I can use my calculator too. And you guys can use your calculator too, if you have the new operating system. This is a negative number, but what's this going to be? Okay, so it's going to be negative 2, and it's 1 minus 2 to the 11th. Whatever that is. Do you want me to show you on the calculator how to do it? Oh, you don't? It's really cool. You just type in this summation. Okay. So if I don't want to add all that up, is that surprising that it's that big, 2 to the 11th? This is n equal to 0, 1, 2, 3, 4, 5. Where'd you get 11? Because I said the 10th term, and it says n plus 1. Yeah, I could do 100. I just chose 10 because I didn't want the numbers to be so darn big, but they are. This is the equation of the first n terms. No. But what we're going to do is we're going to go from there, and we are going to take the limit of this as n goes to infinity, but I'd like it to converge. Pay attention, you'll be okay. This is just showing you what it is. Okay, here's what I want to do is I want to take the limit and let n go to infinity. Now, can I pull the limit through that a over 1 minus r? Yes, because this doesn't affect that. So the limit as n goes to infinity. You're going to see what's going to happen, just patience. Because a is a number, r is a number, and has nothing to do with n. Sam? That is the right side. Oh, in this particular case, yes, we actually should have done n minus 1 there. Because we started at 1. That's why. Write it out. Write it out. We're going to get there. Write it out. That's going to be the question. How do you find a and r? But first, let me get through this. I just did a simple example. Oh, it's not that simple, but a simple example. You'll see it. I promise. I promise. You will. Okay. I want to take the limit of this right here. And it's the limit as n goes to infinity of 1 minus r to the n plus 1. And now you remember you can distribute the limit operator in the parentheses as well. This is going to relate to what we did, was it last Friday? 1 minus r, and it's the limit of 1. What's the limit of 1? 1 minus the limit as n goes to infinity of r to the n plus 1. Remember when we did the r to the n, that sequence? I want to know when that will converge. What has to be true about this? What if r is equal to 2? Will that converge? That diverges. What if r is equal to 1? Well, be careful. If it's 1, first of all, I got two issues if it's 1. Here it's 1 minus 1 to the n, which is 0. But guess what this is? 1 minus 1 is 0. And what happens when we get 0 over 0? We don't know. I don't know. So it can't be 1 either. How about r equal to 0? Yeah, that works. I want this to go away. I want it to go to 0. So what values for r will that limit go to 0? R's got to be less than 1. What do you think on the other side? Greater than what? Negative 1. I want to find, and I shouldn't call it S of n, I should call it S. I want to find to see if my series will converge as n goes to infinity. And it will converge provided that my R value is between 1 and negative 1. You already know if R is equal to 2, it's not going to work. Oh, well, yeah, we'll do some examples. I'm not going to just throw the concept at you. I got a lot of examples. But, and then we can find what it converges to. Let me summarize it. Is it on my next sheet? Or I'll summarize it right here. I gave you a lot of room. And there it is. It's in the middle of page 3. I did all of this. And there it is. That's what it converges to. This is only for a geometric series. So your assignment is going to be with geometric series. So keep that in mind. The hardest part is recognizing it. There's 2 things we have to do. So should we first do the sequence? Let me write it out. It's 1 plus a half plus a fourth, because this is the way you're going to get it, plus 1/8, and that's 1 over what? 2 to the n. Okay. Remember that a geometric series must be in this form. It's a times r plus ar. Oh, sorry, I wrote that wrong. It doesn't matter. You can do either one. It's a plus a times r plus a times r squared plus a times r cubed, etc. And this is ar to the, a times r to the n minus 1. All this does is, this matters by where you start, but it doesn't matter when you do the problems. So what's a? By the way I wrote it out. What's a? Okay, so a is 1. A equals 1. What's r? How do I get from here to here? That's the common ratio. Not 2, but 1/2. So r is equal to 1/2. And this formula you must know. So S, and this will come back and haunt you all the rest of the year because it's going to show up in a variety of places. And it could show up on the free response part of the exam. I've seen it in a very hidden way. I will bring those problems out for you and show you those. So it's 1 over 1 minus 1/2. Now, I know the arithmetic's fairly easy, but you know what I'm going to do? I'm going to multiply by 2 over 2. Because then I don't have to deal with fractions. So what's the numerator? 2. And then this is 2 minus 1. And didn't we just do it geometrically to say it was 2? Do you want me to do it again? Remember the square? Yeah. So I just use that as a simple example. So when you don't know, because you're going to be given some things in sigma notation, write out the terms. The first value is a. Pardon? That's the sum of the infinite series. And it only sums to something if r is less than 1, or between 1 and negative 1. So what's my a value here? 5. That's 5. This is the starting value. How do you get from here to here? Pardon? Well, tell me how you get from here to here. You multiply by what? I have to get a negative, so it's negative 2/3. Does that work going from here to here? Sign becomes positive. That's that alternating sign. So it's as long as my r value is between negative 1 and 1. Or I could write it in absolute value. How would I write that in absolute value? Absolute value of r must be less than 1. No, I shouldn't hear it at all. Okay, let's find the sum. How do you get from here to, is this geometric? Yes, you're multiplying by a negative 2/3. Does it work here? If I multiply by a negative 2/3, 2 times 2 is 20, 3 times 9 is 27. No, it's times. Okay. So what's the sum add up to? It's a over 1 minus r. So Ori, what does that give me? What's a? And then it's 1 minus r, so it's 1 plus 2/3. And I don't want to deal with the fractions. I can, but I don't want to. So I'll multiply by 3 and multiply this one by 3. So the numerator becomes 15, and this becomes 3 plus 2. So the answer is 3. Can I do it what way? Oh no, you have to come up with an answer. You can do 5 over, and then this is 5/3, which is 5 divided by 3/5. But you know, I have to know fractions. If I do it my way, I don't have to know fractions. Okay, let's try the next one. And we can look into some of the problems out of the assignment. I think I assigned them all. Okay, let's look at example 3. That's the last one we're going to do, and one more theorem, and then I'm not going to go on to example 4 today. Should be, or the other theorem I have to talk about. Because then we'll look at the book, okay? I should not run out of time. Now that's kind of intimidating, Ori. Guys, that's intimidating. What are you going to do with that?
What do you mean? It's going to infinity, so.
Is it a geometric series? Okay, here's what you do when you don't know what to do. Write out the terms. So when n is equal to 1, you can use your calculator for that matter. Well, you know what? On an 84 calculator, just make that 10, and you'll see what it converges to, because if they're going to converge, they usually converge fairly quickly. But let's start with n equal to 1. Then I'm going to get 2 squared times 3 to the 0. Then n is equal to 2. I'm going to add that 2. 2 to the 2 times 2, and 3 negative 1 plus. And if you want me to show you this algebraically, I'm just writing them out. 2 times 2 times, what's the next one? 3. And then it's 3 to the 1 minus 3, which is 3 to the negative 2. Is that enough? Or do you want to do another one? It's 2 to the 2 times 4, 3 to the negative, no, 3. Okay, let's clean this up. That didn't tell me anything. This is 4. This is plus 4/3. This is, what is this? 2 to the 6th. Because it's 2n. So it's squared, and then it's 4, and then 2 times 3 is 6. What's 2 to the 6th? That's 64? Over what? 9. What's the common ratio? What are we multiplying by? Okay, this is 3 to the 0. Matter of fact, maybe we should pull out a 4. Let's take out a 4 because I think it's easier. So this is what? 1 plus 1/3. Maybe it's not easier. Oh, no, we have to do this problem. What are you going to do on the exam? No, you're going to do this problem because these are easy. Did I make a mistake? Yeah, but this is going to be what? Right here. No, it's 2 to the 2. Oh, it's 2 to the 2n. Thank you. That's where I made my mistake. So what is this? Sorry, it's 2 to the 4th, which is 16. Got to check me on these things. I could pull out a 4, but I don't want to. Okay, so what's R? 4/3. What's A? Okay. 4 over 3 to the 0, which is 4. Does this converge? What's your common ratio? Must be between 1 and negative 1. It's 4/3. It diverges.
So it's always like these are always going to be the 1 over like those.
The only ones we can evaluate at the moment are going to be the geometric ones. Tomorrow we'll do another kind that we can do. 3 to the 0. Because the A is the first term in your series. Okay, you can't find S, can you? because it diverges. It diverges because r is greater than 1. Will only converge if r is between -1 and 1. No, you don't want to do that. You first decide if it converges. Okay, the question is, could you find S of n? Yes, you can, but you can't let n go to infinity because it does diverge. Now, if r is greater than 1, it diverges. If r equals 1, it diverges. 1 and -1. Okay, shh, guys, I can't hear. What? And sequences, r could equal 1, but not on series. Good point. Sam. Then I could find the sum. Yes. That gives you the value. Here the question is the series convergent or divergent? I kind of hope it's divergent because then I don't have to do anything. I'm done. Okay. One little theorem, and then so then we can look at some of the homework problems. And right here, it's right here. And we can actually do this next problem, although it is on my next, it's on tomorrow's too. If for a series to converge, the limit of the sequence must go to 0. Be careful with that. If the limit of the sequence goes to 0, does the series have to converge? No. It only works one direction. Right, because I've already told you that the summation of 1 over n, remember that one, the harmonic one? Starts at 1 to infinity. This diverges. Does the limit of the sequence 1 over n go to 0? Yes. So just because the n terms go to 0 doesn't mean that when you add them up, that sum will be a finite number. Okay? So the deal is this sequence has to go to 0 fast. 1 over n does not get to 0 fast enough. 1 over n squared does. Okay? Here's the big thing right here. And you put this in. This is your first series test, and I'll write them up on the board. The first series test is the limit of my sequence 0? If it's not, I'm done. It diverges. The series diverges. If it is 0, then I'm going to have 9 other tests to consider. Hopefully I'll catch something fast. The second one is it geometric? First, you always check for this limit. If it's 0, then you say, well, is it geometric? And I'll tell you right now, the only ones they ever ask you for the value on are the geometric. So if you get a summation on the exam, and it asks you to find the sum of the infinite series, you know it's geometric. You might want to write that down, because that's something that might slip away. So let's look at this one. If the only ones that you will find the sum of the infinite series where it converges are geometric. We will do some collapsing sums tomorrow, but they'll never ask you the sum of a collapsing sum. They won't. So you know it's geometric. If they say find the value of this infinite geometric series, then you know you use a over 1 minus r. So that's easy. I know getting to where we are is not so easy. Okay, so you have all this written down. It's on your paper. Let's quickly look at this example right here. Okay, guys? Eric, does that converge? What is the limit of that sequence? Okay, is everybody able to find the limit of this sequence? And he did it under pressure. He said it's 1/5, because remember, we don't care about the 4, right? You're looking at n squared over 5n squared. Is that 0? Now, I want you to think, if I keep adding a 5th as my series goes on, I keep adding a 5th. Do you see why the series will never converge? I keep adding a 5th. Keep adding 20 cents on to my money. Well, it'll always keep getting bigger, won't it? This has to be 0 that you keep adding on, but that's not a guarantee. So when I know that this Limit is 0. That's good. I know it possibly converges, but I say we know nothing. You'll hear me say we know nothing a lot. That'll be your favorite expression. We know nothing. Correct. The limit of the sequence converges to 1/5, but the series diverges because this limit is not 0. Fun. Tomorrow, I'm not going to get to the questions today on homework. I can see that. But tomorrow, we'll do questions on that. I think we'll be able to get there. Mostly it's examples, and I have to give you the partial sums. But let's look at the homework so you don't get too stuck on it. And I don't want you to have homework over break, but we have a certain, sorry, wrong thing. Certain thing we have to do. So 1 through 10 are pretty straightforward. 11 through 18, I'm on page 572. And it says they're geometric series, so all you have to do is find R. Page 572. Okay, Eric? Page 572. Nope. When they ask you, they say 11 through 18, they say they're geometric. So you know it's S equals A over 1 minus R, provided that R is between 1 and negative 1. So all you have to do is find the R value. Now, if you give you a sigma, you might want to write some of those terms out so you see what R is. Then on 19 through 30, you can't do all of these, but there are some you can do. Determine whether the series is convergent, but certainly you want to look at the limit of your sequence as n goes to infinity of a sub n. That must be 0. If it's not 0, then the series diverges. So if you look at 19 really quickly, you should be able to tell me what the answer is without doing any work. No, if the limit's 0, you got work to do. If the limit is 0, then we must use convergence tests. No. If the limit is 0, I just don't know if it goes to 0 fast enough. I keep adding something on, but is it going to grow? And then tomorrow, let me think about if I can do that harmonic series geometrically. I can do it algebraically, but I think the geometrically might be better. That's this. If the limit of the sequence is 0, then I have to do work. Might converge, it might diverge. We know nothing. Then you're going to have to look to see, well, is it geometric? Okay. So your first test always is to take the limit of the sequence. You guys, I want you to be quiet. If the series converges, then I know for a fact the limit of the sequence had to have been 0. So the limit of this one, I'm trying to think what I was going to say here. You always take the limit, guys, you always take the limit of the sequence, which is this part. What is that limit? It's 1/3. It does not equal 0, therefore the series diverges. I always do this theorem first. There's going to be 10 of these. And guess what? Almost always the limit's going to be 0, and then you have to go and do some other work. One of the other ones. Oh, a lot of times you're going to run into the exam where they'll ask if it diverges or not, and you just look at the limit of the sequence, you say, I'm done. It diverges. This is all multiple choice. Your first test is all multiple choice because this is not on the free response part of the exam. Okay? I'll get it up on Schoology, but it's not, we have to get through 8.4. We're all on 8.2, so not to worry. Because I need that to do one of the tests. Okay, and this time machine is correct. It's real important you try these before tomorrow so you can bring questions, and then we'll do the other kinds of problems. Okay, it's time to go. I'm not here tomorrow morning though, because I